So in this lesson we're going to look at how to find the area of a minor segment, and in case you've forgotten, a minor segment is this area here created when you cut a circle with a chord. The small side of it is a minor segment, that's that one just there. If you are asked to find the major segment, that would be this side over here. But we find that using the minor segment, so that's what we're going to focus on. So what we need to know is how do we find that area? So in the last lesson we looked at the area of a sector, and what we found was that it was equal to a half r squared theta. Okay, so that was just from the last lesson. And what you can see is that minor segment is the sector minus this triangle here. Okay, so to work out the area of the triangle, we need to look at, it's not a right angle triangle, so we're going to be using the half AB sine C rule. Okay, now A and B are the two sides of the triangle on either side of the angle, and in our case, well, the sides of the triangle are both r because they're the radii of the circle. So this is equal to a half times r squared. Now when we talk about sine C, C is this angle in here, which in radians we're using theta. So this formula becomes a half r squared, sine theta. Okay, so then to work out the minor segment, we take the area of the sector and we subtract the area of the triangle. So we end up with a half r squared theta minus a half r squared sine theta, which we can simplify. So that simplifies to a half r squared, because there's your common factor, outside of theta minus sine theta. So that's your formula. Half r squared theta minus sine theta. And again, you now have a formula sheet for that. Okay, so how do we use this? Well, let's have a look at the question. In a circle of radius 1 meter, what is the area of a segment subtending a right angle at the centre to the nearest centimetre squared? Okay, well, what do we know? We know that our formula is a half r squared theta minus sine theta. So we need to know the radius. Well, the radius is 1. That's pretty simple. But that's 1 metre, and they want our answer in squared centimetres. It's a lot easier to convert your metre here. That way your answer will already be in centimetres. So I'm going to write it as 100 centimetres. Okay, if I used the 1 metre, I could change that to centimetres, but what kids tend to do is then say, well, 1 metre is 100 centimetres, so they multiply it by 100. But in area, 1 square metre is 10,000 squared centimetres, and students tend to forget that, especially in exams. So it's much safer to convert that to centimetres first. Okay, then we need to work out our theta. Now they've told us it's a right angle, which hopefully by now we're getting pretty comfortable at saying, well, 90 degrees is pi on 2. If not, just remember you multiply it by pi over 180 to work out what that is in radians. And we need to know what sine of theta is. So sine of pi on 2. Well, what is sine of pi on 2? Sine of pi on 2 is equal to 1. Okay, now if you don't know that, then hopefully in the next exercise, when we start looking at trig graphs, you'll understand why that is. But at the moment, like, if you're not sure, you can type it into your calculator as well. Okay, so now we're just going to do our substitution. So the area is equal to a half times r squared, so 100 squared, outside of theta, so pi on 2, minus sine theta, so that's 1. So into your calculator, because they want it to the nearest centimetre squared, so I don't want the exact answer. So that goes into your calculator. You end up with 2,854 centimetres squared. So that's how you do the area of a minor segment. It's not terribly difficult. It's exercise 5.5. Good luck. I'll see you in class.